Okay, so in this one, we're gonna tackle the concept of binomial expansion. Hopefully at this point, you understand enough about Pascal's triangle to fill in your own. It's gonna be super important that you do because this will just save you time. You saw in the video how the pattern is formed, but in case the video was not shown or we didn't see the Pascal triangle, like how we make it, here's the pattern. Every outside row is 1, all the way down, left and right. And then to find the inside numbers, you sum the two numbers that are above it. So 1 and 1 become 2. 1 and 2 become 3. Okay? 3 and 1 become 4. All the way down. And this goes forever and ever and ever. Okay, so for us to be important, we're going to talk about these numbers and we're going to use them in binomial expansion to shortcut the problem. But we're going to talk about it in terms of rows. So technically this is row 0 at the top. We don't really use that for our purpose, but that counts as row 0. This is row 1, row 2, row 3, and so on and so forth. So if we kind of ignore row 0, we can tell what row we're looking at by the first number in the line that's not 1. So row 3 begins with 1, 3. Row 2 is 1, 2, right? Row 6, 1, 6. Okay, so if I say row 6, this is the one we're going to use. You don't necessarily need to count or have them labeled. That's just the connection there. And you can see I filled in a decent amount of this triangle. I went down to row 10. You might need more than that, you might not, but it's not that hard to put this together. It's tedious, it takes a little bit of time, but it's not difficult. Okay, so here we're gonna use Pascal's triangle to expand some binomials. All right, let's go down and look at number 3. I changed number 3. So number 3 will look like for me this. 2r plus t cubed. All right, so we need to make that change. We need to make that change to be cubed because it's going to be different, obviously. So what we do here is we look and we say, okay, it's cubed. The exponent is 3. I'm going to find the third row of Pascal's triangle, and I'm going to find those numbers. So in the third row of Pascal's triangle, I have 1, 3, 3, and 1. Okay. Once I have those numbers written down, I'm going to create columns. Like this. Okay. So here's my setup. Okay. So now what I'm going to do is I'm going to take the first term and I'm going to highlight the last term. And I'm going to do things just to these terms. I'm going to ignore the plus or the minus in the inside right now. I'm going to ignore that until the very last step, and I have a shortcut for that too. So the first thing I'm going to do, okay, this guy, the first term, it is going to be cubed because I'm going to kind of distribute this cube in. So this thing is going to get cubed. 2 cubed r cubed. Okay, it's going to get 3 exponents going to it because that's the row I was in, that's the exponent. As I work my way to the right, I'm going to keep writing this over and over, but every time I'm going to lose an exponent. So it's going to be 2 squared r squared, 2 to the 1 r to the 1. And then eventually, I don't have, like, the next thing would be 0. So 2 to the 0 power is actually just 1. And r to the 0 power is actually 1, so like this ends up just being 1 over here. We don't really need to write a 1. We can just put a blank. 3, 2, 1, we run out, leave it blank. Okay. Now, this, I don't know, let's go the other way. Okay, t. Now, I went from left to right. Now I'm gonna pick up where I left off and I'm gonna start here. T is gonna get all 3. And then as I work to the left, I'm going to lose 1 all the way along. And then I'm gonna run out as I get to here. Okay. So far, relatively easy pattern. To the left, to the right back, making sure that we just take all the terms. So here's the thing, right? T squared, I don't know what that is. I can't simplify that anymore. R cubed, same deal. No clue, it's fine. But 2 cubed is a real number. I can figure out what that is, and I need to. Okay, so let's see here. 2 to the 1 is actually just 2. 2r. 2 squared is actually 4. And then the r squared comes along with it. And then 2 cubed is actually 8. Okay. I need to figure out what the real numbers are. Okay. Now, I'm at a point where I can get my final answer. So what I do is I take these columns and I multiply the real numbers by the real numbers. Remember, this top row counts. So 1 times 8 is 8. And then I go back for the letters. I only see r's here, and I see that I have 3 of them. Okay. Real with real, 3 times 4 is 12. I see I have 2 r's, and I have 1 t. 3 times 2 is 6, and then I have 1 r, and I have 2 t's. And in the final column, I just have a 1, so I'll write 1 maybe. And I only have 3 t's, t to the 3. Okay. So this is building my final answer. It's basically right here. The last thing I need to do is figure out the glue that's connecting these terms to each other. And I will look up here for that. When it is a plus, it's easy. Everything's plus. Everything plus. When it's a minus, we're gonna go minus, plus, but we'll see that in a second. So here is my final answer. I have taken this binomial and I have expanded it to be like this. Okay. Let's take a quick look at this answer and notice a little bit of pattern. I have in my first term 3 exponents, right? R cubed. I have 3 exponents. In my second term here, I still have 3 exponents. I have 2 r's and 1 t. That makes 3. Here, I have 3 because, hey, I didn't write the 1 that time, but it's implied, it's invisible. So 1 plus 2 is 3. And then finally at the end, I have 3. Here's a quick check that you can do to make sure you did it right. Your exponents should always add to be the row that you started in. Okay, so I should have 3 exponents because I did the 3rd row. Okay, so that was that example. Let's do number 2. And I'm gonna use the 5th row of Pascal's triangle because I have a 5 here. So my numbers here are 1, 5, 10, 10, 5, 1. Again, those numbers came from the 5th row of our triangle. And now I'm gonna make my columns. Okay. All right, as you set up your rows, I'm going to set up the rest of the problem. My first term is j, it's just j. J gets all the 5s. And as I work my way over, I'm gonna lose an exponent every step of the way. And then I run out of j's. So just every step, take 1 away. Now for my second term here, I'm going to take the whole thing, ignoring the negative. I'm going to take the whole thing, 3k. I'm going to start where I left off, except now I'm gonna give this one all of the exponents, 3 to the 5, k to the 5. I'm gonna work my way over here, losing one. 3 to the 4, k to the 4. 3 to the 3, k to the 3. 3 squared, k squared. 3 to the first, k to the first, and then I should run out because I will have 0 of them as we end up. Okay. All right. Just like the last problem, k to the 4th is just gonna stay k to the 4th, but the 3 to an exponent, that's a real number that we can evaluate. 3 to the 1st is just 3. 3 squared is 9, 27, 81, 243. And these are the numbers that I'm gonna multiply when I get down to my final step here. Okay, so I've set up the problem, I found the pattern, I did the thing. Let's multiply our columns. 1 is the only thing here, like real number wise, right? So I have 5 j's, j to the 5 is this column's output. This column is a 5 times a 3 for 15, and it has 4 j's and 1 k. 10 times 9 is 90. This one has 3 j's and 2 k's. 10 times 27 is 270. J squared, k cubed. 5 times 81 is 405. With 1 j and 4 k's. And then lastly, 1 times that is that, 243 with all 5 k's. Okay, so we found the output of each of our columns. Now, if this was a plus, this would all be pluses, just like the last problem. But it's a minus, so slight different pattern. I'm going to have minus first, in between the first two terms, and then plus. And I'm gonna alternate all the way down. And that's what that pattern looks like. Minus, plus, minus, plus, minus, plus. So that's the only other change that you have to worry about. This big old thing is your answer. And if you wanted to do that extra step of double checking to make sure you are on the right track, you are in the 5th row, so your exponents should add to 5, 4, 1, 3, 2, 2, 3, 1, 4, 5. We did it. Okay. This takes practice, and we can do that with practice.